Okay, so let's try this functions question. Question 9. I'm going to do part 1 and part 2, even though you guys didn't rank them as being hard, but they actually help us for part 3, so it's important to look at why that works. The first one is finding the first derivative, and just be careful. In the exam, sometimes it can be easy to mistake the derivative sign for an inverse sign. People have done that before. So this is alchemy for the derivative. I'm going to write it out as a negative power first, like that. And then I'm going to differentiate it. It is a composite function, so just be careful that after you multiply the power and take a power off, like that, oops, it should be negative 5, that you check inside the brackets there. And when we differentiate this, I get negative 3. So I would times that by negative 3. So I get 15, 1 minus 3x to the power of negative 2. For part 2, when it asks me with a reason whether this is an increasing or decreasing function, all you have to remember is that increasing functions is, or the increasing part of a function is when the gradient is positive, and decreasing is when the gradient is negative. So if I rewrite this out without the negative power, in a sort of natural sort of form like that, what we've got on the denominator of our fraction here is, whatever x value we put into here, we're going to square it, and whenever you square a real number, it's going to become positive. It means the denominator of our fraction will always be positive. The numerator of our fraction is always positive. So that means that this derivative is always positive, which means the gradient's always going to be positive. So that means it's an increasing function. Okay, so that's your reason for that. Okay, now for part 3, we have to look at the inverse function. We have to look at the domain and range. And when it's been quadratics, I've made you guys draw the quadratics and look at the vertex and kind of examine that, so you know what the domain and range is. In this case here, what we've got is not a quadratic. We've got what's called a hyperbola. And I think it's sort of important to have a look at how they behave, just really quickly. This is a negative hyperbola. And it's a little bit like how you can tell negative parabolas, is that you look at the x squared term, and if that's a negative x squared, it's a negative parabola. In this case here, if we look at the x term here, it's a negative 3, which means that it's a negative parabola. So I'm not going to draw it accurately in that it's not positioned where I'm going to draw it now for you, but I just kind of want you to get the idea. So it looks a little bit like this one here. And so what happens is that you're going to have some asymptotes like this, and you're going to get these nice sort of curvedy bits on each part. Okay, so this is what we've got here, and we're looking at this only from x equals 1, because the domain of our curve is that x is greater or equal to 1. And what we need to know is what the values for y can be, because it'll be the range of our original function. And then when we find our inverse function, we'll just swap the domain and range around. So to get what the y value is at that point, that's not too bad. All we do is we take the function and we work out what it is when x equals 1, so f of 1. So we just substitute in 1 for x, and what we're going to get there is negative 5 over 2. Okay, so that means that when x is 1, our function is negative 5 over 2. But also, because our hyperbola is never going to go above the x-axis, we actually know that our function, the range actually looks like this. So it can be as low as negative 2.5 or 5 over 2, and it can go all the way up to, but not actually equal 0. And the other way that you know that is to look back at the original function. So even if you didn't know what it looked like, I suppose, on here, you know that it's an increasing function. So that means that the gradient is always positive. So from the point that we're looking at, which is x equals 1, you know the function is always going up from there, in which case after you've substituted in your x value to get your y value, you know that all the other y values have to be above that x value, that y value. So you'd know this. How would you know, though, that it wouldn't go any higher than 0? Well, you just have to go back and look at this original function here. So if you imagine putting in, I don't know, x equals 100, okay, into this expression, you get 1 minus 300, which is negative 299, and then 5 divided by negative 299 is a pretty small number, right? And let's say put a million in, so 1 minus 3 million, 5 divided by 1 minus 3 million. Again, it's a really, really, really small number. And the thing is, there's no combination you can get that's going to give 0 as your y value, because you can't make the denominator 0. So therefore, it's going to get smaller and smaller and smaller and smaller and smaller, but it's never ever going to get to y equals 0. Okay? Cool, so now we have our domain and range for the function. All we have to do is actually get the equation of the inverse function, and then we can swap our domain and range around, and we'll be done. Cool. So let's go back to our original function, which was y equals 5 over 1 minus 3x. If I swap my x and y around, like so, and then I start to do some solving. So some rearranging. Y minus 3y equals 5 over x. Then I'm going to run out of space, aren't I? Let me move some stuff up while I can. Okay. So then negative 3y is going to equal 5 over x minus 1. And then, so if I move over here, so y, I'm going to divide everything through by negative 3. Yeah, so I'm going to get negative 5 over 3x, and then I'm going to get positive or plus 1/3. So then my inverse function is this, negative 5 over 3x plus 1/3. And then I need to restate alongside that what the domain and the range are for my final function here. So okay, so my domain is going to be what the range was before. So that means it's going to be as low as negative 2.5, and it's going to be up to, oops, that should be an x, sorry. And it could be up to but not including 0. And then my range for this one here is that the function is going to be greater or equal to